Hello and welcome to Computational Thinking Lesson 3. So hopefully this is all becoming clearer for you. So same learning objectives and criteria as the previous two lessons. So you're going to understand the 5 concepts of computational thinking. Then I'd like you to understand what computational thinking is, identify and discuss each stage, computational thinking, and then solve some problems based on stages of computational thinking. So, once again, what is computational thinking? And hopefully you know this, or if you don't know it, it's becoming clearer. So, computers are made to help us solve problems. So as I've discussed in other lessons, the first computer was designed to solve equations that may have taken hours or days for brilliant mathematicians. So they designed a mechanical machine that would do it for them very quickly. A bit like calculators are designed for us to do basic maths very quickly, in a matter of seconds. So now humans can do all of this themselves, but a computer just does it much quicker, okay? So before the problem can be tackled, it needs to be understood. If you don't understand how to solve the problem, you can't tackle it. Now, computational thinking allows us to take a complex problem, understand what it is, and develop possible solutions, so then we can present these solutions in a way that a computer, a human, or both can understand. Now, remember what the 5 stages are? If you want to remember what the 5 stages are yourself, pause this video now and just quickly try and remember them. If you pause the video, welcome back. So it's decomposition, pattern recognition, abstraction, algorithm design, and debugging, okay? If you got all of those right, why not put a comment underneath the video? So, looking at a problem. So if we remember, a complex problem at first glance, we don't know how to solve it and we become overwhelmed. So the wonderful thing about computational thinking, and I'm hoping it's something that maybe you can take through all your subjects, is when you look at this problem, don't become overwhelmed. Think, how can you break it down? So what we do is decompose the problem into a series of smaller problems. Then we recognize the patterns and try to see how each problem can be solved individually and recognize any similarities. Then you recognize the important details and dismiss the irrelevant details. And then a set of instructions can be made for us to basically solve the problems. So this lesson, you're going to look at abstraction. Okay, so we're going to abstract a problem. So abstraction is a process of filtering out or ignoring the characteristics of patterns that we don't need in order to concentrate on those that we do. So what we do is we filter out any, specific details from this and create a representation of an idea of what we're trying to solve. So it allows us to create a general idea of what the problem is, okay? So basically you can say, right, well, dismissing this, dismissing that, dismissing that. What we're looking at here is this problem. And then we can try and figure out a way how to solve it. So sometimes you can get caught up in smaller sections. Now, the great thing about pattern recognition is that it solves problems, smaller ones. But then sometimes we can end up being caught up in solving these smaller problems and then just forgetting what the problem ever was in the first place. So the process of abstraction is to remove specific details and patterns, and then this becomes our model. So if we look at this example, now in my class you may have seen this before, maybe in other schools you've seen this before. So we're given a set of instructions here, okay? So what we can do is we can actually break down this one by one and we can try and solve what these smaller problems are. But if we was to look at this in terms of abstraction, so if you was to sit here and do this exercise right now, okay, and if you remember in my other classes, we all had different things. But if we was to say, okay, the general idea, let's abstract the general idea. You're drawing a kite. Then it's easier, isn't it? Okay, then you can actually say, oh, okay, I understand now. Draw a diagonal line. Oh, right, so that makes a cross. And number 3, okay, so yeah, I can do that. So if we was to say this is what you're drawing, then it's easier. Okay? Right. Now, another thing is, so if we was to abstract a problem, okay, so if you was to say to someone, who is Joe Wicks? Okay, who is Joe Wicks? Now, let's abstract that and put this into little tiny bits. Like, Joe Wicks, he's known as the body coach. Joe Wicks is a TV presenter. He's an author of diet cookbooks. His methods are, fitness methods include HIIT workouts, which are high intensity interval training workouts. He's a YouTuber. He's an Instagrammer. He's a record breaker, okay? He was awarded remotely the Guinness Book of World Records for the most views on YouTube live stream, where he was teaching children PE while they've been at home in lockdown. He's the husband of a model. He's the father of 2 children. He's known as the nation's PE teacher in the UK during the corona pandemic. Okay? I mean, maybe these last 2 bits don't matter at all about who Joe Wicks is. But the general idea, if we was to abstract this, the general idea is Joe Wicks is a famous fitness YouTuber or a famous fitness social media YouTuber, a famous fitness guru on social media, because Joe Wicks first became famous from his Instagram account. Okay, now you're going to do some abstraction yourself. Okay, so look at this worksheet, and what I want you to abstract is, what noises do dogs make? What happened to Henry VIII's wives? Who is David Beckham? What is the weather forecast for today? What are the key skills needed to be a hockey player? Okay, very best of luck to you.